And we are now in Module 4B. We are still learning how to solve quadratic equations. And if you guys and gals recall, a quadratic equation has an equation with an x squared term. And we already learned that that means we're always going to have two solutions. The last module, we learned how to solve a quadratic using our factoring skills because we learned to factor a lot in algebra. Today we're going to find out in this Module 4B what happens if you cannot factor a quadratic equation. So let's go to our notes. If you look up here, I have the equation x squared minus 8 equals 0. It obviously is quadratic. You see the x squared. It's already set equal to 0. Step 1 is done. So what we learned the other module is that you would factor it. Here's the problem. Let's go through the rules of factoring. Can you do the Gcf rule? Does x squared and 8 have a term you could divide them by? Absolutely not. You cannot divide a variable and a number by the same thing. So we can't use the Gcf rule. It is obvious we're not going to do the trinomial rule because what does the word trinomial mean? It means 3 terms. And we only have 2 terms here, x squared and negative 8. So the trinomial rule's out. So the only other rule of factoring we need to look at is difference of perfect squares. Well, if we look closely, there's the difference sign. Difference means subtraction, so we have that. But the rule is called difference of perfect squares. And a perfect square is a term times itself. So let's look at each term and see if it's a perfect square. Is x squared a perfect square? Yes, it's x times x. Is 8 a perfect square? No, it is not. We all know 8 is 4 times 2, and that's not the same number. So because 8 is not a perfect square, you cannot use the rule difference of perfect squares to factor this. Therefore, we can't factor. So you're going to say, okay, we just can't solve the equation. Yes, we can. We just need another method. So the second method we're going to use to learn how to solve a quadratic equation is an operation that you've already learned in algebra. As you all know, squaring means to multiply something times itself. Well, there's an opposite operation to squaring, and if you recall, that's called a square root. So that's what we're going to do today. We're going to learn how to solve a quadratic equation by square rooting. Now, to square root, you have to make sure you only have the 2 terms. You have the term with the x squared, and you have the constant, the number. So that's what we have here. We have an x squared, and we have an 8, a constant. So we're going to learn how to solve this doing the square root method. Now, if we look closely, to solve doing the square root method is a different procedure. It's just like being a surgeon. It's a different procedure you follow if you were going to take out somebody's tonsils versus their appendix. So last week we were learning how to factor. That procedure said set the equation equal to 0, factor, write 2 linear equations, solve them. Today we're going to do the square root method, totally different procedure. So you got to memorize this procedure also. So to solve using the square root property, the first step is to isolate the x squared. You want to get on the left side of the equation the term that has the square. And you want the numbers to move to the right. So to solve by the square root, you do not, I'll repeat that, you do not want the equation equal to 0. You want it equal to a number. So we're going to isolate the square, move the numbers to the right. Then we're going to square root both sides. And you all know how to square root. You're going to understand that when you square root, you're going to have to break it down, and you're going to have 2 answers, so that's where a plus or minus symbol is going to come in. So let's go to the whiteboard. I have 4 examples to work with you guys today. So let's take this first example. Here's our quadratic equation, x squared minus 8 equals 0. We've already decided it will not factor, so we're going to do the square root method. So we have a different procedure. Step 1 today is get the constants moved. Move any number over to the right. So we're going to move the negative 8 by adding 8. So we get x squared equals 8. Step 2 is to square root both sides. To physically do the opposite of squaring, which is square root, square root. What happens is, just like adding and subtracting are opposites, we cancel them out. Squaring and square roots are opposite, so they cancel out. And that just leaves you good old x. And that was your goal. Your goal in solving an equation is to find out what x is. Here's the problem. It's the right side. First of all, there's going to have to be two answers. The only way to get two answers out of square rooting is to put in front of this square root symbol a plus or minus. Now you're going to say, why do we do that? Well, think about it. Square rooting means something times itself. And we all know a positive times a positive makes a positive 8, and a negative times a negative would make a positive 8. So the rule of thumb is every time you do the square root method, once you draw the square root symbol in, you put a plus or minus to show there's going to be two answers. Now, the last problem with doing the square root method is understanding this cannot be the final answer. Square root of 8 has to be broken down or reduced. And we've already discussed this from Module 3. To break down square roots, you'd use perfect square numbers. What perfect square divides into 8? It's 4. So this would break one down into the square root of 4 and the square root of 2. I leave the plus or minus in the front. So now I have x equals plus or minus. What times itself is 4? That's 2. Because you could square root 4, you get a whole number. Can you square root 2? No, so it stays inside. You now have two solutions. And you could leave it in this form, or you could write it out. First solution is 2 square roots of 2. The second solution is negative 2 square roots of 2. There's two answers there. They're different, but we have two solutions. Okay, let's try another quadratic doing the square root method. So example 2, 18x squared equals 2. It says solve. We obviously know it's quadratic. It has the x squared. First rule in solving by using the square root method is to move all the numbers that you can to the right. So everybody look, this 18 has to move first. How is 18 connected? By multiplication. So we do division. If you remember your rules of exponents, the square only belongs to the x. It doesn't belong to the 18. So that's another reason why we're moving it. You isolate the term with the exponent. This cancels out. We get x squared. 2 divided by 18 is a fraction. We reduce it. We get 1/9. Do not make decimals. In college algebra, we prefer the answers to be fractions. Now we're going to do the opposite of squaring. We're going to square root both sides. Squares and square roots are opposites, so they cancel out. That's where we get the good old x equals. Automatically, we're going to put it. What symbol? A plus and a minus to say we're going to have two solutions. And we have the square root of 1/9. Now, can we leave the square root of 1/9? Absolutely not. We've learned in algebra, this square root belongs both to the numerator and to the denominator. So the square root of 1 is 1, the square root of 9 is 3. So we have two answers here. X is negative 1/3 and x is positive 1/3. Not that bad, right? It's just a different procedure. Now I know what you all are thinking. You're coming up with your own rules and saying, oh, this is easy. Every time you get an answer, one's going to be positive, one's going to be negative, but they're going to look the same. No, that's not the case. All I'm guaranteeing you is every time we solve by square root, you're going to get two answers. Okay? Let's try a third example. This one's going to be a little bit more difficult. Okay? So let's erase this. All right, we have 4x plus 3 squared plus 6 equals 11. Pretty big equation, right? Now, I'm going to be honest with you guys. Here's part of the problem in college algebra. I could be very specific and say to you, solve this by factoring. Solve this doing the square root method. Or I could just be very vague and just say solve and leave you to choose. Sometimes both methods work, but your goal is always to find the quicker method. I'm not going to lie. You could sit here, write the 4x plus 3 2 times, because that's what squaring means. You'd multiply that out by FOIL. You'd get your trinomial. Then you'd have to multiply everything by 5 and add 6, subtract the 11, get the equation equal to 0, and then try to factor. There's nothing wrong with that, but as we learned, factoring is not guaranteed. So why would you want to do all that work, get the equation equal to 0, and then realize it won't factor? So this is why we have other methods. A better choice here would be, hey, you know what? I see a square. The opposite of squaring is to do the square root method. But now we got to follow the procedure. To do the square root method, the first step is always move all the constants we can to the right side. So we got to start moving. So obviously we'll subtract 6. That's an easy move. That'll cancel out, and 11 minus 6 is 5. Now wait, we're not done. We have another number here that needs to move to the right. You cannot take that 5 and multiply it to the 4x plus 3. You cannot distribute or multiply first, because remember, exponents would go first. So what we're trying to do is we're trying to isolate who owns the exponent. And this exponent belongs to all of this because it's in parentheses. So that's what we have to get isolated. So we're going to move that 5 by division. 5 divided by 5 cancels out. That leaves us with the 4x plus 3 squared equals 5 divided by 5 cancels out, which makes the number 1. So we did step 1. We moved everything over. We can't move anything else because these numbers are stuck in parentheses. So now we can get rid of the square by square rooting. Squares and square roots are opposite operations. They cancel out. That's going to leave us the 4x plus 3. And because it's on the left side by itself, we don't need the parentheses. Equals, what are you going to remember to put? Plus or minus, because we got to have two answers, square root 1. So far, so good? Now, we know we can't leave this in a square root. So we have 4x plus 3 equals plus or minus. What is the square root of 1? Well, it's a perfect square. It's 1. So what you've done, guys, is think about it. You started out by having a square being quadratic. Now do you have a square? No, you're linear. But to solve this, you can't start moving things because you have plus or minus here. This plus or minus means this left side could equal 1. This left side could equal negative 1. So you need to break this up into two linear equations. 4x plus 3 equals the positive 1. 4x plus 3 equals the negative 1. And now you're back to algebra 1. We'll solve each. 4x equals negative 2. We'll divide by 4. And we all know negative 2 over 4 has to be reduced to negative 1/2. There's your first solution. Now, I know what you're thinking. Oh, this answer is going to be positive 1/2. That's not the case. You'll always get two solutions with a quadratic, but they don't have to be opposites of each other. So we're going to solve this. We're going to subtract 3. Negative 1 and negative 3 adds to negative 4. We're going to divide by 4. And x equals negative 1. So see, we still got two solutions. This time they're both negative. But this was a different procedure. Okay, let's try one more, and this one last example will show us how those imaginary numbers are going to come into play. Because we haven't seen that yet. All right, so our last equation we want to solve today is very simple. It is 2x minus 1 squared equals negative 8. Again, we know it's quadratic. We got a square. You have options here. You could write 2x minus 1 twice and then FOIL it out and get a trinomial here and then move the 8 over. But remember, just because you get a quadratic equal to 0 doesn't mean it's guaranteed to factor. So why do all that work? It is very obvious. To get rid of squaring, you do the square root method. So the first step is to move any constants over to the right. So I'm going to ask you, can we move anything? No, we cannot. The 2 is stuck in parentheses. The 1 is stuck in parentheses. They're stuck here. There's nothing to move. So we jump to step 2, which is, hey, the opposite of squaring is square root. Squares and square roots cancel out. That's going to leave us our 2x minus 1. We don't need the parentheses anymore. Equals, what are we always going to put? Plus or minus square root of negative 8. Now we talked about this. You can't leave a square root unless it's broken down. So 2x minus 1 equals plus or minus. Uh-oh, what do you notice? This square root is a negative number. And we've already discussed this. The square root of a negative number from Module 3 is not a real number, it's imaginary. If we break this down, what perfect square is an 8? It's 4. So this would be 4 times 2 times negative 1. That's what you're saying, how you get the negative 8. So we have 2x minus 1 equals plus or minus. What's the square root of 4? Well, that's 2. Can we break down the square root of 2? Nope, it stays inside the symbol. But we learned the square root of negative 1 is imaginary. And what do we use to show imaginary? That's right, we use the I. So here's the first time now you guys are going to see when we solve equations who says the answers all have to be real answers. The answers in college math can be imaginary or complex. So that's important. Anytime you're dealing with square roots, you could get an imaginary answer. So now we got everything done except, is x by itself? No. You can't move stuff right now because this is a plus or minus. So you can't move these terms yet. You have to physically write how many equations? That's correct. We got to write 2 equations. So our 2 equations are going to be 2x minus 1 equals positive 2i square root of 2. 2x minus 1 equals negative 2i square root of 2. And now let's solve. Now you're going to see how you use all your algebra skills. We're going to add 1 to both sides. 2x equals, can you add 1 a real number to 2i square root of 2 an imaginary number? No, you cannot. We learned in Module 3, you always put the real number first. So 1 goes first, and then plus 2i square root of 2. Now the opposite of multiplying by 2 is dividing by 2. X equals. Here's the problem. You learned in Module 3, when you write an answer with an I, it has to be in A plus BI form, which means I need to see a real number and then an imaginary number. I need to see 2 terms, 2 parts. So you can't leave this as one big fraction. We all learned from algebra, this division bar means to divide both of these by 2. Well, 1 divided by 2 is a half. That's your real number. Plus 2i square root of 2 divided by 2. Because this is connected by multiplication, we can divide. These 2's will cancel out and leave us I square root of 2, which is your imaginary. And that is your first answer in A plus BI form. So just remember, if you have an I in your solution, it has to be written with the real number first and then the imaginary part. We'll do the same thing here. We're going to solve. We're going to add 1. You can never add a real number to an imaginary number, so the real number goes in front and then the imaginary part. We're going to do the opposite of multiply by 2, which is divide by 2. Now, some of you may remember in algebra, your teachers told you, you know what, write this as 2 fractions. It's 1 over 2 minus 2i square root of 2 over 2. And if you write it as the 2 fractions, you can obviously see the real number is a half minus these 2's are going to cancel out because you're connected by multiplication, and here's your imaginary. So you have 2 solutions, okay? If you look very closely, they have a special name. They're binomials, they're 2 terms. One has a plus and one has a minus. So do you remember what those are called? Very good. They're called conjugates. So here's an example where we solved a quadratic. We got 2 imaginary answers, and they were conjugates of each other. Okay, so now you have under your belt 2 different, totally different procedures to solve quadratics. There's the factoring procedure. There's the square rooting procedure. The problem is, and I know this sounds horrible, Sometimes neither one of them work. So when I see you in the next module, we're going to find out what do we do if we have to solve an equation and these methods don't work. Thank you.